Hello, good evening. Welcome to City Part-4. In today's session, let us continue with the problems of solving linear equations in two variables. Yes, in the previous class, we have discussed substitution method to find the solution for the linear equations in two variables or for simultaneous equations. I have done the simple problems as well as the little bit harder one, and we have solved two word problems also. So in today's class, let us do two more word problems which are little more harder than the previous problems, and then go for another method. So ನಿನ್ನೆ ಮಾಡಿರೋ ಪ್ರಾಬ್ಲಮ್ಸ್ ಜೊತೆಗೆ ಇನ್ನೆರಡು ಸ್ವಲ್ಪ ಕಷ್ಟ ಅನ್ಸೋ ಪ್ರಾಬ್ಲಮ್ಸ್. ಕಷ್ಟ ಏನಲ್ಲ, ಯಾವುದು ಕಷ್ಟ ಅಲ್ಲ, ಆದರೆ ಸ್ವಲ್ಪ ಲಾಸ್ಟ್ ನಿನ್ನೆ ಮಾಡಿರೋ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಇರೋ ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಇವತ್ತು ಮಾಡೋಣ. ದಟ್ ಈಸ್ ಫ್ರಮ್ ದಿ ಸೇಮ್ ಎಕ್ಸರ್ಸೈಸ್ 3.3. ಎಕ್ಸರ್ಸೈಸ್ 3.3. Okay, so let us not waste the time. Let's continue with the fourth problem in the exercise 3.3. This third main, fourth problem. The problem is the taxi charges in a city consist of a fixed charge together with the charge for the distance covered. For a distance of 10 km, the charge paid is rupees 105, and for a journey of 15 km, the charge paid is rupees 155. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling a distance of 25 km? First, let us understand the question. ನೀವಿಗೆಲ್ಲ ಟ್ಯಾಕ್ಸಿಲಿ ಹೋಗ್ತಾ ಇದ್ರೆ ಅಥವಾ ಆಟೋದಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ರೆ ನೋಡಿರ್ತೀರಾ, ದೇರ್ ಇಸ್ ಅ ಫಿಕ್ಸ್ಡ್ ಚಾರ್ಜ್ ಫಾರ್ ಕಿಲೋಮೀಟರ್ 30 rupees ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಆಟೋ ಇನ್ ಬೆಂಗಳೂರಲ್ಲಿ ಆಟೋಗೆ ಫಿಕ್ಸ್ಡ್ ಚಾರ್ಜಸ್ 30 rupees. ನೀವು ಎಷ್ಟೇ ದೂರ ಹೋಗಲಿ, ವಾಟ್ ಎವರ್ ವೆದರ್ ಇಷ್ಟು ದೂರ ಮೀನ್ಸ್ ಮಿನಿಮಮ್ 2 kilometers ಒಳಗೆ ಎಷ್ಟು ದೂರ ಹೋಗಲಿ, ಇವನ್ ಇಫ್ ಯು ಟ್ರಾವೆಲ್ ಫಾರ್ 1 kilometer ಯು ನೀಡ್ ಟು ಪೇ 30 rupees. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಫಿಕ್ಸ್ಡ್ ಚಾರ್ಜ್. ಜೊತೆಗೆ ಎಸ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಯು ಹ್ಯಾವ್ ಟ್ರಾವೆಲ್ಡ್, ಎಷ್ಟು ದೂರ ಹೋಗ್ತೀರಾ ಅದ್ರ ಮೇಲೆ per kilometer jump ಆಗ್ತಾ ಇರುತ್ತೆ ಮೀಟರ್. You might have observed this. Okay, so that type of problem is this. Okay, so here the taxi charges in a city. Okay, but a person is traveling for a distance of 10 km. The charge paid is 105 rupees. So the person has traveled 10 km distance and he has paid 105 rupees. And in the same taxi, if the person travels 15 km, then let us consider another person has travelled 15 km, the charge paid is 155 rupees. Okay, so total charge paid is given here. Okay, so we need to find how much is the fixed charge ಎಷ್ಟು, ಹಾಗೆ yes per kilometer how much he needs to pay. Per kilometer jump ಆದಂಗೆ ಎಷ್ಟು ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, that we need to calculate here. Okay, so first let us consider the fixed charge as X rupees and the charge per kilometer as Y rupees. Okay, let's continue the problem now. It is a problem exercise 3.4, 3.3, exercise 3.3, fourth main, exercise 3.3, third main, fourth problem. Okay, third main, fourth problem. Third main, fourth problem in your state textbook. Okay, third main, fourth problem. So let us do this sum. Let X and Y, that is rupees X and rupees Y is X and Y be the fixed charge and charge per kilometer respectively, or you can write let x be the fixed charge and y be charge y rupees be the charge per fixed per charge per kilometer, charge per kilometer respectively. Now, according to the question, first case, in case 1, person has travelled 10 kilometer. Okay, so case 1, let us take here, person has travelled 10 kilometer. So for x is the fixed charge plus if 1 for per kilometer, that is for 1 kilometer, if he has to pay y rupees, for 10 kilometers how much is 10y, it is 10 into y, okay, 10y. Total how much he needs to pay? He has paid 50, how much? 105 rupees, 105. This is equation 1. Second case, here the person has travelled how much? 15 kilometer distance. Okay, so here also x is the fixed charge. Okay, plus 15 kilometer means 15y, 15 into y is equal to how much? He needs to pay 155 rupees. So let us consider this as equation 2. Now what to do in substitution method? First we need to convert any one of the equation for the required form. Okay, let us take second equation. So I will take from equation 2, I convert equation 2 as now x is equal to 155 minus 15y. Okay, this is the required form. I will keep one variable on LHS. X I can take here. Okay, taking as depending variable and y as independent variable. So 155 minus 15y, transpose 15y to the RHS. So minus 15y. This is equation 3. Now what to do? Substitute equation 3 in 1, not in 2, because we have converted equation 2 into required form. Again we cannot substitute the same in this. Okay, so what to do now? Substitute 3 in 1. Substituting equation 3 in equation 1, we get, in place of x now, I need to write 155 minus 15y is equal to, not over, this is x value plus 10y here. Plus 10y is equal to 105 or 105. Simplify this equation and we have single variable here. Okay, now if it is single variable, always it is easy to solve. That means we get a linear equation in one variable. You know how to solve it. Let us simplify now. So 155, it is 155 minus 15 plus 10. It is equal to minus 5. So 155 minus 5y is equal to 105. 105. Now let us find the value of y. Let us keep minus y here itself. Minus 5y is equal to 105. When I transpose 155 to RHS, it becomes plus 155, becomes minus 155. Yes, minus 5y is equal to, yes, plus 105 minus 155. What should be done here? Subtraction, because one is having plus sign, other one is minus sign. Subtract and put greater number sign. So 155 minus 105, what do we get? 50. Which sign we need to write? It is minus sign, because 155 is greater number, it has minus sign. Both these sides we have negative sign now, so it gets cancelled. That means minus by minus we get a plus 5. So y is equal to, what do we get now? 50 by 5. How much it is? It is 10. Okay, 5 tens are 50. 10. So what is this y? Y is nothing but what? charge per kilometer. For 1 kilometer he has to pay 10 rupees. The person or the traveler has to pay 10 rupees. So why 10 is equal to 10 rupees? Let us find x value using this now. So what to do? Put this value here in equation 3. Any of the equation you can use here. But let us take equation 3 because the directly it is given x is equal to, we have done here. So put x is y is equal to 10 in equation 3. In equation 3 we get x is equal to 155 minus 15y. It is 15 into 10. 15 into 10 how much? 150. So 155 minus 150 how much? 5. So fixed charge how much? 5 rupees. I think once upon a time in our state, isn't it? I already 30 rupees agogide. So but here in this for taxi it is. Okay, so textbook ಮಾಡಿರೋದು ಯಾವುದೋ ಕಾಲದಲ್ಲಿ ಸೊ ಅದೇ ಚಾರ್ಜಸ್ ಈಗಲೂ ಈಗ ಉಳ್ಕೊಂಡಿದೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ. So it is equal to 5 rupees. Fixed charge is 5 rupees and charge per kilometer it is 10 rupees. Okay, so let us write the answer now. Conclusion part. Therefore, fixed charge solution is 5, 10. If you want to write the pair of solution, it is 5 and 10. So right now, therefore, fixed charge is rupees 5 and charge per kilometer. Always after solving the problem, you must write the conclusion statement. Charge, because we have two values here, isn't it? Charge per kilometer is equal to rupees 10. So 10 kilometer, 10 rupees per kilometer. Rupees 10. This is the solution. How can you check your answer? Take these values, substitute in any of the equation. Let us take first case. 5 rupees plus 10y. That is 10 times are how much? 100. Okay, 100 plus 5 how much? We get 105. Here also 5 rupees plus 15 times are 150. 150 plus 5 how much? 155. So the problem is solved. Okay, so let us now continue with next problem. Before that, I'll give you 2 minutes to complete the problem for those who are copying the sum. I hope I can erase now. Okay, so let me take next problem. It is 6th problem. Okay, 5th one, just let me discuss how to get the equation. After framing the equation, yes, you can do this problem your own. Let me explain 5th problem. Second 5th problem explain ಮಾಡಿಬಿಟ್ಟು next we go for 6th one. I don't do it on the board. Okay. A fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. Okay, so fraction becomes 9 by 11 if we add if 2 is added to both the numerator and denominator. So here numerator and denominators are not given. If 3 is added to both the numerator and denominator, it becomes 5 by 6. Okay, find the fraction. So, here if I take fraction as x and y, x by y, that is x is the numerator and y is the denominator. In the first case, what is added? Here 2 is added for both, that is x plus 2, y plus 2. Then what do we get here? By that we get 9 by 11. This is one of the equation. How to get? Cross multiply and simplify. It is 11 into x plus 2 is equal to 9 into y plus 2. You will get one equation. Second case. If 3 is added to both the numerator and the denominator, it becomes 5 by 6. So 3 is added in the second place. X plus 3 plus y plus 3 is equal to 5 by 6. Here also is cross multiply and simplified. You will get a linear equation in two variable. So you get two equations from this. By this you can solve them. So this is the way of framing the equation. Now let us go for sixth problem in this. Sixth problem is 5 years hence the age of Jacob will be 3 times that of his son. Okay, 5 years ago Jacob's age was 7 times that of his son. What are their present ages? Okay. So this type of problems are very important. Almost in all the exams you will get this type of question. Year related problem, age related problems. Okay. So let us do this problem now. 5 years hence means what? 5 years after. After 5 years, the age of Jacob will be 3 times that of his son. So what should be taken as x and y now? Present ages. Okay. If the present ages of Jacob and his son are x and y, 5 years hence means after 5 years it will be, suppose Jacob's age is 40 years now. 5 years later how much it would be? 40 plus 5, 45. Son's age, how much here? 3 times of that. Okay, suppose y is the son's age now. Y plus how much? 5 years. After 5 years means y plus 5. So suppose 10 years now. Now after 5 years it would be how much? 10 plus 5, 15. Okay, so here that is the first case. Then 5 years ago. 5 years ago means how much here? Munche. 5 years muginta munche. Yes, if now present age is x rupee, 5 years ago how much it is? X minus 5. Okay, 45 idre. Yes, sorry, 40 idre. 5 years ago it is 35. Okay, similarly for son, suppose he got 10 years idre, 5 years ago it would be 5 years. But there is a condition. Using that condition, we need to solve the problems. Okay, so 5 years hence the age of Jacob will be 3 times that of his son. So first let us write, let x be age of Jacob. Let Jacob's age be x years, and son's age be, his son's age be y years. Now according to the condition, that is first case, let us take now. First case is here 5 years ago. 5 years hence means after 5 years. 5 years hence, or that means after 5 years. After 5 years. Jacob's age would be how much here? X plus 5 years. Okay, Jacob will be x plus 5 years and Jacob will be x plus 5 years and his son will be y plus 5 years. Their ages will be x plus 5 years and y plus 5 years. But what is the condition given here? After 5 years, this age, which one Jacob's age will be 3 times. Okay, yes, 3 times of his son's age. So, given that given that Jacob's, that is x plus 5, will be equal to how much? 3 times of sun's age means 3 times y plus 5. Simplify this. You will get an equation now. So x plus 5 is equal to 3y plus 3, 5s are 15. Simplify this. I'll keep x here itself because I want, anyway in the third step we need to take, instead of that, ನಾನು ಈಗಲೇ ಇಟ್ಕೊಂಡ್ಬಿಡ್ತೀನಿ. So x is equal to 3y plus 15. I shift 5 to RHS, so minus 5. So x is equal to 3y, 15 minus 5 is 10 plus 10. This is equation 1. Okay, equation 1 is x is equal to 3y plus 10. Now let us take second case. In second case, 5 years ago. Okay, 5 years ago means munche. 5 years ginta munche. So 5 years ago. 5 years ago. Jacob's age will be, Jacob's age, how much here? It was x minus 5 years. Jacob's age was x minus 5 years. And his son's age was, it is y minus 5 years. Y minus 5 years. But here what is the condition? It is 5 years ago, Jacob's age was 7 times that of his son. Okay, 5 years ago, Jacob's age was 7 times that of his son. So, x minus y, given that x minus 5 is equal to what? 7 times y minus 5. Okay, simplify this also. X minus 5 is equal to 7y minus 7 5s are 35. Okay, 7y minus 35. So, write x, I bring 7y here now, minus 7y is equal to, I write minus 35 here itself, and transpose minus 5 to RHS, it becomes plus 5. So x minus 7, that is 1x minus 7y, what do we get? Minus 6y. Minus 6y is equal to minus 30. 35 minus 5 is 30. Greater number is 35, it has minus sign. So it is minus 30. Both the sides we have negative signs, so it gets cancelled. So y is equal to, what do we get? 30 by 6. How much it is? 6 5s are 30. So y is equal to 5. Okay. What is this now y? Y is son's age, present age of son. Okay, 5 years. Okay. Now Jacob's age will be, how do you find the value of x? So first you substitute this y value in any of this equation, either in 1 or in 2. Okay, so this is equation 2. Which one? This is equation 2. X minus 5 is equal to this one, equation 2. Y value we got here directly. Sorry. So x minus 7y is equal to minus 35 plus 5. Sorry, here I have taken this also same variable. So x minus 7, let us get the equation. X minus 7y is equal to, it is minus 30. This is equation 2. Okay, this is equation 2. So now what to do? X minus 7y is equal to minus 30. This is equation 2. Let us substitute this equation 1 in equation 2. Substituting. After framing the equations, your one big task is finished. Okay, then substituting. Equation 1 in 2. Equation 1 in 2. We get, in place of x, I need to write 3y plus 10 minus 7y is equal to minus 30. Simplify this. 3y minus 7y, what do we get? 3y, 3 plus minus 7. It is minus 4. Minus 4y is equal to minus 30. I shift 10 to right hand side plus 10. So it becomes minus 10. Minus 30. Minus 10. So y minus 4y is equal to minus 40. So y value how much? Minus minus 10 gets cancelled. So y value is 4 ones are 4 tens are. Therefore y is equal to 10. Y is equal to 10. Yes. Now let us substitute this value y is equal to 10 in any of the equation. I will take one only because direct equation. So and get the value of x. I think you have finished this part. Just give 1 minute and erase this. So put y is equal to 10 in equation 1. We get x is equal to 3y, that is 3 into 10 plus 10. It is 30 plus 10. 3 into 10, 30. 30 plus 10 is 40. So what is this 40? Jacob's age. So Jacob's age is 40 years and son's age. His son's age is 10 years. These are current ages, the present ages of these people. Therefore, write the conclusion now. Jacob's age means it is understood present age. Jacob's age is 40 years, x value, and his son's age is 10 years. Yes, how can we verify your answer now? Just apply the condition. Yes, according to the question, here 5 years hence, after 5 years, then Jacob's age will be how much? 45. Okay, 45 years. Then son's age will be how much? It is 10 means here, it is after 10, 5, 15 years. How many times more? 45 is 3 times 15. Similarly, other one, before 5 years, that means 5 years ago. 5 years ago is 45. This 40 minus 5, how much? Jacob's age will be 35. 5 years ago. Then son's age how much? 10 minus 5. It is 5 years. How many times more? 7. 5 are. Okay, 7 times more. So our condition is satisfied and we got correct answers. Copy this. So now let us go for another algebraic method to solve linear equations in two variables. Which is that method? That is called elimination method. First method was substitution method. By substituting one equation in another, we get the solution in that method. Now this is elimination method. Yes, what is elimination method? This name itself says here. Okay, elimination means what? Removing one something. Okay, removing something. So similarly here, well, in linear equations in two variables or simultaneous equations, yes, you will have two variables, isn't it? X and y or a and b or any like this, two variables. So by eliminating one variable from the given equations, what do we get? We get a linear equation in one variable. If we have linear equation in one variable, you know how to solve it. Okay, very easily we can solve the equation and get the values of the variable. After getting the variable, again what we have done here in the previous method or the substitution method, we have to substitute that value in any one of the equation and get the other one. So this also, actually comparing with this is actually more simpler. This method, which one? Elimination method. Okay, so let us go now with the problem. I'll explain the problem only, then you can understand very clearly. Let us write the heading elimination method. Elimination method. This is second method. Second method to solve linear equation in two variables or simultaneous equation. So it is elimination method. We go now. So let me explain with an example. Let us go with the first problem in exercise 3.4. Here also I'll go with simple one first. Okay. So first main it is solve the following linear equations by elimination method and substitution method. And the substitution method means yes, we need substitution method here also. Okay. So first one, x plus y is equal to 5. Okay, example, I'll take it as first problem in first main. This is exercise 3.4. 3.4, first problem in first main. So x plus y is equal to 5 and second equation is 2x minus 3y is equal to 4. These are the equations given. So x plus y is equal to 5. In the first step, what should be done? Okay, whenever as soon as you see the equation, first we need to check, is there any variable in both the equations with same numerical coefficient? Here, what is the coefficient of x? 1. Here, coefficient of 2. No, we don't have. Here, coefficient of y is 1. Coefficient of y is minus 3. We don't have. So, what to do? First, we have to change any one of the equation to make it equal. Okay, so any one of the variable must be equal to eliminate that. Okay, then either depending on the sum, either we need to add or subtract. So x plus y, we have to change the first equation because that is the simple one. X plus y is equal to 5 is the simple one. So we change this equation now for required form. Which is better to take? Here we have minus 3. So okay, in this equation if we get plus 3, by simple method, that means by simply by adding we can eliminate one of the variable. Okay, so what to do? To get plus 3 by here, what should be multiplied here? We have to multiply throughout the equation by number 3. Okay, so let us take this is equation 1 and this is equation 2. Okay, now let me multiply equation 1 by 3. So throughout the equation means each of the term must be multiplied, not only y or any constant. Okay, throughout the equation we should multiply. So 3 into x plus y for the RLHS and here 5 into 3. Okay, so what do we get? 3x plus 3y is equal to 5 3s are 15. This is equation 3. Equation 3. Now let us add equation 2 and 3 because here we have plus 3y, here we have minus 3y. If we add them these terms, okay, y term get cancelled. Okay, so we write by adding we write here 3x plus, for all of your row this one column method is easy. I use that method only now. 3x 3 plus 3y is equal to 15. The other one 2x minus 3y is equal to 4. Nothing to do because they are adding. So 3y minus 3y gets cancelled. Here 3 plus 2, 5x is equal to 15 plus 4 is how much? 19. Okay, 5x is equal to 19. So what is the value of x? 19 by 5. So x value, which implies by that we get x value 19 by 5. What is the next step? We have to put this value in any of the equation, either in equation 1, 2 or 3, any. Which is better? Equation 1 is simple. So let us substitute in that equation. So x value 19 by 5 by substituting, or put, you write it is easy, put x is equal to 19 by 5 in equation 1. We get 19 by 5 plus y is equal to 5. So y is equal to, let's transpose this, 5 minus 19 by 5. What is LCM or denominator, common denominator? It should be 1, 5. Because this is nothing but what? 5 by 1. So 5 should be multiplied to both the numerator and denominator. So what do we get here? Y is equal to 5 5s are 25 minus 19 by 5 is the common denominator. So 25 by 19, what do we get here? 6 by 5. 6 by 5. Okay, so y value 6 by 5. Okay, so x is 19 by 5 and y is equal to 6 by 5. So the solution is, this is not a statement problem. So we must write the conclusion. Therefore, conclusion as here, the numbers as pair of numbers now. So therefore, the solution is x value should be written first, 19 by 5 and 6 by 5. 19 by 5 and 6 by 5. I hope it is clear, this method, very simple. Copy this. Let us do with another sum, little harder one. I take fourth one in first main. Here the statement equations are given in terms of fractions. So let us go with that. This that. So the problem is fourth one. This is first main, fourth one. X by 2 plus 2y by 3 is equal to minus 1. This is equation 1. And the other one, x minus y by 3 is equal to 3. This is equation 2. What should be done first? You have to get the simpler form of this equation. If it is in the form of fraction, definitely it will be difficult to solve. Okay, so what to do? First, let us bring it to simpler form. By taking LCM of the denominators or getting the common denominator. In the first equation, what is LCM of 2 and 3? It is both are prime numbers, so we need not use the row factorization and all. Just by multiplying that, then we get the LCM or common denominator. So 2 into 3, 6. 6 is the LCM. So here 3x plus here 2 into 2, 4y. So we write equation 1 can be written as, that is, this implies 3x plus 2 2s are 4, 4y by 3 2s are 6 is LCM is equal to minus 1. Transpose 6 to RHS, that means we need to multiply minus 1 with 6. So this implies 3x plus 4y is equal to minus 6. This is equation 1. So equation 3. Okay. So we have changed equation 1 into equation 3. We have not changed the question. Just written the same equation in another form. That's all. Okay. We don't have the right to change the question. Okay. Just we are changing the question form from one form to another form. Okay, now let us go with second one now. Here x means what? X by 1. So what is LCM of 1 and 3? LCM of 1 and 3 is 3 itself. Okay, so equation 2 can be written as, if I take this as 1, so multiply both the numerator and denominator by 3. What do I get here? It is 3x, that is 3 by 3x we get here. 3x minus 3 ones are 3, so into 1, so nothing is changed here. Minus y by denominator, common denominator is 3 is equal to 3. Convert this, transpose the 3 to RHS, so we get 3x minus y is equal to 3 3s are 9. This is equation 4. Now let us solve equation 3 and 4. Okay, this is another form of equation 2. Just we write equivalent fractions now. Like that we are writing equivalent equation. That's it. Now let us go with these equations 3 and 4 and solve them. So, yes, by solving equation 3 and 4, to solve what should be done? See the coefficient. Do we have any common variable with common or equal numerical coefficient? Yes, we have. In the first equation we have 3x. In the second equation also we have 3x. So this is common, but with same sign. So we need to change the sign. If you change it into minus, what do we get? We can eliminate them. So what to do? We need to subtract. In the previous problem we have added, because nothing here they had different signs, unlike signs. One is for plus sign, other one is for other one was with the negative sign. So here, but here we have both of same sign, 3x, here also plus 3x. Okay, let us subtract now. Now subtract, that is equation. Either you can subtract 3 minus 4 or 4 minus 3, both are fine. So equation 3 minus equation 4 I will take now, that is by subtracting. I take 3x plus 4y, 3x plus 4y is equal to minus 6, and the other one 3x minus y is equal to 9. So in subtraction what should be done? We have to change the sign of the second equation which is to be subtracted. So change, plus 3x becomes minus 3x, this minus becomes plus, and this plus becomes minus. 3x gets cancelled. So 4y plus y, it is 5y is equal to minus 6 plus minus 9 is minus 15. Therefore y is equal to minus 15 divided by 5. So what do we get? Minus 15 by 5. Answer is minus 3. 5 ones are 5 3s are minus 3. Y value minus 3. The next, here y we got minus 15. Both are having same sign. So that should be added and put same sign or greater number sign. Greater number is 9. It has minus sign only. Now in the next step what to do? Put y is equal to minus 3 in equation either 1, 2, 3 or 4. But don't take these two. It would be little bit complicated. So what to do now? Take either 3 or 4. Okay, let me substitute this in equation 3. Put y is equal to minus 3 in equation 3. Equation 3, we get 3x plus 4y is 4 times minus 3 is equal to minus 6. So 3x minus 4 3s are 12 is equal to minus 6. 3x is equal to minus 6 plus 12 if I transpose. So we get 3x is equal to 12 minus 6 is 6 plus 6. So x value 6 by 3. X value 6 by 3 is 3 2s are 6. So x value 2. So what is the solution? Solution is minus 3 and y value minus 3, x value 2. So how to write the solution? 2 minus 3. Don't write minus 3 2. Okay. Always while writing the solution, we must write x value first and y next. Therefore, the solution is 2 and minus 3. 2 and minus 3. Okay. Yes, students. So, today you have learned elimination method. This is one of the algebraic method. Today we have done simple problems in this. Tomorrow, again we deal with the word problems or statement problems. So, let us end today's session. Please, all of you join the session along with your friends and ask them to subscribe the channel. So, let us end today's session. Thank you. Thanks for joining. Bye-bye.